Now, today we are going to learn with the example of AVL tree insertion. So, suppose this is the AVL tree. So, first we cross check the balancing factor. As this node doesn't have any child, so its balancing factor will be 0. This node doesn't have any child, so its balancing factor will be 0. This node is having one child on left hand side, one child on right hand side. So, plus 1 for left hand side, minus 1 for right hand side. So, total it will be 0. Total it will be 0. 110 doesn't have any child, so its balancing factor will be 0. And here 96, it is having 2 level on left hand side, so we can say plus 2 because on left hand side always plus, and right hand side 1, so it will be minus 1. So total it will be plus 1. Total it will be plus 1. Balancing factor of 96. Now suppose if we are inserting one element, we are inserting one element in this tree, that is 36. That is 36. So where we are going to insert, because it's based on the concept of binary search tree. So we can say here that whatever root is here, less than that it will come on left hand side, right? More than this will come on right hand side. So 36 is there. 36 is there. So we will put 36 on left hand side. So we will cross check 85 again. 85 is more than that, so again we will cross check for 64, and 64 is there, so 36 will come on left hand side of 36 will come left hand side of 64. So the next tree will be like this. 96 we are adding, 85 say 36 over here, 36, 90 and 110. Now 36 will come left hand side of 64. Now after adding 36, again we will cross check the balancing factor, because AVL tree is basically based on the balancing factor. If all are balanced, then no need to do any rotation, but if it is not balanced, then we need to do rotation to make it AVL tree. To make it AVL tree. So here we are able to see that all are 0 and plus 1. So tree is balanced. Now we are inserting 36. So after inserting 36, we will see what are the balancing factor. So 36, because it doesn't have any child, so its balancing factor will be 0. 64 is having one child on left hand side, so its balancing factor will be plus 1. 90 doesn't have any child, so its balancing factor will be 0. 85 is having two child on left hand side and one child on right hand side. So plus 2 minus 1, it will be plus 1. 110 is having no child, so its balancing factor will be 0. Now 96, 1, 2, 3. 3 levels are there, so plus 3, and here one level is there, so minus 1. So total it will be plus 2. Left hand side 3 levels, so plus 3. Right hand side 1 level, so minus 1. So total it will be plus 2. Now we are able to see clearly that balancing factor is plus 2. While in AVL tree, when we can say AVL tree is balanced, when balancing factor are 0, plus 1 and minus 1. But it is more than 0, plus 1, minus 1. So what we need to do? We need to make it balanced. To make it balanced, what we supposed to do? We need to do rotation. We need to do rotation. So we are able to see in the last lecture which kind of rotation we will do, because we have inserted the element left subtree left side. We have inserted the element 36 left subtree left side. So the rotation, what we supposed to do? We need to do LL rotation. What we supposed to do? LL rotation. LL rotation. And LL rotation, as we have discussed in the last lecture, LL rotation, so we will skew the tree right side. We will do rotation right side. So this is the important point. See here carefully what we are trying to do. What we are trying to do. So this is the tree, and if we are skewing the tree on right hand side, so how it will be? It will be like this. This is the tree, and if we are skewing the tree right side because of LL rotation, so it will skew like this. It will skew like this, right hand side in right direction. So 85 will go up. 85 will go up. We are skewing the tree like this, right hand side. So 85 will go up. 85 will go up. So we are making it like this. 85 will go up. So 96 will go down. 96 will go down, and After that, what will come? 110 will come over here. And because 85 will go down, 85 will go up because of the right side rotation. So 96 and 110 will come down, and 64 and 36 will come here. 64 and 36 will come over here. And now, what is left? 85 is here, 96 is here, 110 is here, 64 is here, 64 is here, 36 is here. But what is left? 90. What is left? 90. Then where we should put 90, because 85 is the root now. 85 is the root now, so 90 can't come over here because of the property that whatever root is there, left hand side less number of the value will be less, and right hand side value will be more than the root. So 90 is more than the 85, so it will come on right hand side, and it will come on left hand side of 96. It will come left hand side of 96. Why? Because as per the rule, according to the value of the root, the less value will be left hand side of the root, and more value will be right hand side of the root. So 90 is more than the root. Now root is 85. Initially it was 96. After rotation of right hand side, 85 become the root. So 90 is more than the 85. So we can't put on left hand side. So we need to put on right hand side. So it will come on right hand side and left hand side of 96. Now rotation has completed. Now again we will cross check the balancing factor of the AVL tree. If it is balanced, then no need to do any rotation. If it is not balanced, then again we have to do rotation. So now we'll cross check. 36 doesn't have any child, so 0. 90 doesn't have any child, so 0. 110 doesn't have any child, so 0. 96 is having one child on left hand side, one child on right hand side, so balanced, so it is 0. Plus 1 minus 1, it is 0. 64 is having one child on left hand side, that is 36, so because of left hand side, it is plus 1. Now we will see 85. There are also two levels, here also two levels. One level, two level, one level, two level. So both side balanced. Left hand side also two level, right hand side also two level. So balancing factor will be 0. So now we are able to see the balancing factor of AVL tree are 0 and plus 1. So it is balanced, because we can see the AVL tree is balanced whenever balancing factor are 0, plus 1 and minus 1. When it is more than that, then we have to do rotation. We can say that it is not balanced. So we are able to see clearly whenever we are inserting any element on left hand side, left subtree left side, so LL rotation will be there. And how we do it? Because LL rotation, so we'll skew the tree on right hand side. And after skewing the tree, we have to see that our root is changed. So we have to see that whatever elements are there, they can come on left hand side or not. Otherwise we have to add on right hand side, or if they are on right hand side and whatever way is there, we have to follow the properties. And after that we have to see the balancing factor. If balancing factor is 0 or plus 1, then tree is balanced. So in this way we can do the rotation. Next example of insertion and rotation we will see in the next lecture.